time for convolution. And this star means this integral. Y of t is equal to minus infinity to plus infinity of a variable, a dummy variable, lambda, h, t, which is time, minus the dummy variable, lambda, delta lambda. Okay. So you have a function of time, h of t. For example, x of t. X of t equal to t squared. So here it will be lambda squared. It will appear as lambda. Here you have a function of time, h of t. For example, h of t equal to t. So here it will be t minus the lambda. So what you will do, you will convert, first of all, you will create h of lambda first, and then you will flip it in the opposite direction. It will become h of minus lambda, and then you will time shift to the right. But you will add it by a t in front of that. It will become h of t minus lambda. So eventually we will end up having a function of t and the lambda. Lambda is the variable of integration, and x a function of lambda. Then you will proceed integrating with lambda varying from minus infinity to plus infinity. Outcome of that integration will be a function of time, y of t. This function of time is called as the convolution of the x of t and y of t. Theory. There is a theory that shows, that's the Laplace tool, that the Laplace of this convolution outcome is equal to, straight away, Laplace of x multiplied through multiplication, like times, Laplace of h. Because remember we said every function of time had a Laplace. So these are true functions of time. So if you Laplace that and do the other function of time, you Laplace that, you multiply the two Laplaces together, it will give you the Laplace of the convolution. Now, if you want to determine the outcome of this integral, simply you can inverse transform the y of s, because you got it, you figured it out. So let me put it this way. Because the concept is too abstract, I'm not forcing it that much into my students, but I'm going to explain what it is going to do. I'm not going to go to the details of that, but you can do it via Laplace tools, and you can get the answer very easily. There is an example, which is a homework example. I used the Laplace theory, avoided the convolution integral, and I got the answer that you need. It's in the book. But let me give you the physical meaning of it. What is the convolution? Okay. Say you have a system that has a transfer function of h of s. Okay. And you know what is the inverse transform of h of s. This is h of t. What was the inverse transform of a transfer function? Do you remember? We said it's the impulse response. So to a kick there, if the system has a response like that to the kick, this is the h of t while you're applying a delta t, and h of t is nothing but inverse transform of h of s. Okay. If you have this given, or known. If you apply a function such as x of t at the input, instead of the impulse, this impulse, a true kind of, general purpose voltage you apply to the input, we want to know what will be the output, this output, y of t. So this will be the outcome. Y of t will be equal to the convolution of x of t with h of t. Convolution of this waveform, input waveform, with the impulse response of the system is the output of the system, the physical output of the system. So system output is equal to convolution of input x of t with the impulse response of system, which is h of t equal to inverse of h of s. So that's the meaning of that convolution. So you've got a system here, x of t, and it is tested. It is tested. How do we test them? With an impulse. You put boom, and then you see what kind of a wave it generates. Keep that wave. That's the function you need. Convolute that function here, h, with another input that you're feeding in, not the impulse, but some kind of a generic input that you're giving, a general input, any x of t. Then, if you want to know how the output waveform is going to look like, you simply run the convolution integral through this dummy variable lambda, and then the outcome will be a function of time, and that's it. That function of time is the output. So this statement gives it a physical meaning. Remember, this star is not multiplication, it's convolution. It speaks for the integral. That sign speaks for this operation. Okay. So, how can we then determine if somebody throws to you this problem? You have I'm giving you an x of t, I'm giving you h of t, find the convolution, like the homework problem. I'm going to resort to sort of cheating. Instead of doing it with the convolution, which we are supposed to do it, but it is a little too abstract. The operation is multiple. I will go this way. You want the convolution of x of t and h of t? Maybe it's an output of the system. Okay, this is what I will do. I will take x of t, Laplace transform, h of t, Laplace transform, comes back to the transform. Multiply the two, you get a new transfer function. That is the Laplace of the convolution, the output, convolution of the two. You have the Laplace, get it inverse transform, you translate it into time. So that's what it is. Yes, I kind of cheated here. I didn't go into the integral itself because the steps to carry it out, this integral, is listed in the book. Please go to the section of the book that says convolution. You read those steps, see if it is clinging to your to your head and logic, how to carry it out. It's a little bit too abstract. So I'm not going to spend too much time or waste my time, but I will give you a solution for answers like what is the convolution of two function if it is given to you. You can go around the problem and solve it. So this is the problem that we have. So let me just cut this short. What's the physical meaning? Why do you need to convolute two things together? Because when you apply an input to a system and you expect to see an output, that output will be the convolution of impulse response of the system with what you're feeding. So that's the physical meaning. It is impulse response. Impulse response of the system is a set thing. You cannot change it. It's the system itself. So this function ht comes from the hs, the transfer function, and it is a set thing. It's a given coming with the structure. But this one, input, is the one that the structure takes and convolutes by itself and delivers it as an output. Kind of, mixes or processes that and turns it as the output. Okay, so let's go to a typical problem there. Remember, you want to convolute to a function. The cheating way, the shortcut would be transform to Laplace, multiply, inverse transform. That's it. You answer that integral, which looks a little abstract. Now, let's look at the example. Let me check my time. Yes, we have time. So this is the example. You have a function there. This function is x of t, and then you have and that function is 2, 0 to 5. So otherwise it's 0. 0 rises to 2, goes back to 0. You have another function, t, which is rising to 5, stays there for 3 seconds, then it comes down, 3. This is h of t. Okay. What would be the convolution of these two functions together? So according to the book, you have to flip this, like rotate around this ordinate, flip it that way. So it will be pulsed this way. Then you have to shift it by amount of t to the right. So if you move this, the 0 stays there, 3 will go to -3, and then shift it by a t. So the 0 will move to t, the other end of that will move to -3 plus t. Then you will start integrating that with lambda. So you will change this variable of time on each one into lambda. You will keep the t there, and then you will keep for various values of t as you're shifting from 0 all the way to infinity. You will get the integration. You will multiply the functions together, integrate, and find the result portion by portion, segment by segment. Try to do that. See if you'll find it comfortable. Here, so I did it in a different way. I said, look, if this is x of t, h of t, you want the convolution of the two, y of t equal to x of t convolution h of t. This is what I will do. I will translate x of t into, I will describe x of t. X of t is going to be a 2u2ut minus 2u of t minus 2u of t minus 5. What does that mean? 2ut is a step going like this to ut minus 2ut minus 5 is a step that is 0 all the way here. Then it takes opposite. So if you combine these two functions, red functions here, with that, what is the output? 0, 0 plus 0 is 0, 0 plus 2 is 2, and then 2 plus minus 2 is 0. So automatically you can create that mathematical statement for x of t. And then immediately Laplace transform x of s. X of s over that will be 2 over s, 1 minus e to the power minus 5s. You will get that by the shift theory. The first one will be 2 over s. The other one is also a step, but it's a shifted step by a 5-second delay. So it will be minus 2 over s to the minus 1. Now, next, create another functions for that one. I'll use green. This is made from a step that rises to 5, and then another delayed step that comes in and cancels it by minus 5. So add these two greens together. Here, 0, 0 is 0. Here, you have 0 from this one, 5 from that, so it gives you 5. The sum is 5. This part, you have a 5 from the top, minus 5, they add up to 0. That's it. We build this function. So the h of t is therefore equal to 5 over t, 5 over s, multiplied by 1 minus e to the power minus 3 s. Okay. So I factor, 1 over s. Actually, it is 5 over s for the top. For the bottom is minus 5 over s, minus because equals negative, shifted by 3. Laplace transform, the shift property. Check that one out. Now, this is not h. I'm sorry, this is the big h of s. Because h of t, yeah, that h of t is 5 ut minus 5 u of t minus 3. That's the mathematical statement in time domain, and this is the essay. Now, remember what I told you about the theory. Convolution of x of t and h of t is actually equal to Laplace of that is equal to product of Laplace of the two. So that of the you have the Laplace of both. So simply multiply together. So your times h of s by then you will find the two. So multiply these two terms together, it will give you a term like here, 10 over s squared, 1 minus e to the power minus 3s, e to the power minus 5s, plus e to the power minus 8s, okay? S, distribute. I showed how you will distribute them. So each one will come up to y of t equal to inverse transform of 10 over s squared. Then you will have minus inverse transform of 10 e to the power minus 3s over s squared. Then minus inverse transform of 10 e to the power minus 5s over s squared. Then plus inverse transform of 10 over e to the power minus 8s over s squared. You will have that. Then you will transform into the following function. So this is our final function. From the tables, by looking at each function, 10 over s squared will be y of t equal to 10t ut. It's the rank. Remember, s squared. 10 unit of a rank. 1 upon s squared would be tut, 10 would be 10t. It's a line. This one is again line because it's s squared, but it is shifted by a 3 second, but with a 10 unit. So it is a minus 10 t minus 3 u of t minus. All of them are coming from the shift theory. Then you have this is check, this is check. You have that term. It will be 10 minus 10, of course, minus 10. Again, t minus 5, t minus 5, u of t minus 5. And finally, the last one will be plus 10 over t minus 8, u t minus 8. Okay. So bear in mind the properties of these functions. For time interval between 0 to 3, before 3, from 0 all the way like 2.99, all the way say to just before 3, 2.99, all these terms are vanished. They don't exist because they become 1 after that. So t has to be greater than 3, in order to greater or equal to 3 to become 1. So for time interval, all the ranges of time interval, you keep inspecting what stays, what term stays, what term goes out. And I've done a table for you. Here's how to do that. This is the table. So I wrote, here is your answer, y of t. Take the time interval more than or equal to 0, but less than 3. Which one stays? Be the judge. None of them to the right, only 10t. So it's going to be 10t ut. This is going to stay. So the answer will be, in this time interval, your convolution of these two functions will be 10t. Otherwise, it will be 0. You know, like t less than 0, they're all 0. Next, what about time greater or equal to 3, but yet less than 5? Here, less than 5. So let's see what will stay and what will go. For time greater than 3, this term is in, so you have 10t. This term is in, so you have minus 10 times t minus 3. But that term is non-existent because it is less than 5. It hasn't come in. So here is your outcome. Add them up. So you get minus 10t cancels this. You get plus, this becomes 30. That's it. Answer 30. Next. For time interval greater or equal to 5, but less than 8. This is the way to do it. And that integration of convolution would be that way, but even worse because of its abstract nature. You have to work with a dummy variable lambda, but yet, you know, extract time concepts out of it. I find it a little hard to digest. So here, let's see what will stay, what will go. T greater than 5 means this term is in, that term is not. So how many terms I have? I have a 10t from first. I have minus 10 t minus 3 from the second. From that one, I have minus 10 t minus 5. So add them up, see what stays, what goes. So the outcome would be 80 minus 10t. This will be portion of the convolution result. And final thing is t greater or equal to 8, but less than infinity. Here, what will happen? Now we have t greater than 8. T greater than 8, this term stays. So terms that are staying are 10t minus 10 t minus 3, the second, minus 10 t minus 5, and finally that term is in because t is greater than 8, so it is 10 t minus 8. Add them up, the outcome will be 0. So if you put all of that description with their times into a picture, what will come out of here? The answer would be, this would be the wave convolution for you. Going ramping up, staying there, coming down, going to 0, start 0, rises to 30, and 3, 5, then goes down to 8, flattens to 0. This is the convolution of x of t and h of t. Okay. So I am done with the whole thing, gentlemen. Next week we are going to have a lecture. I will try to quickly review as what we did. Put emphasis on the sections that we did. There won't be any kind of problem solving. If you want me, I can problem solve for you. Then, that will be the end of the whole course. And we will be ready the following week for an exam, which, again, I will explain next Thursday how I'm going to set up the exam. The exam will be emailed to you 1 hour before the school time, the scheduled time, and you are supposed to email it back to me up to 1 hour after the ending. So that will be our routine. The reason that I'm emailing 1 hour before the start of the exam is because you never know, delays within the transfer of emails. I'm considering that into account. However, if you get within 15 minutes of my transmission, that's fine. Get started early. And if you finish early, you want to send it in early, do it. But we have to make sure that it is no more. Make sure even if you are emailing back, it is before the time so that, it won't be prolonged. I don't want it to be prolonged. That's the only way I can assess you. And it will be an optional exam. You have to answer 2 questions, like straight questions, mostly homework, the circuit from homework, circuit from AC parts, circuit from here or concept from here. I'll put them together. And then 4 of them, you have to answer 2. That's presumption. And then you have everything in your disposal, references, everything. Send it back, and then I will grade and pass it grade into the system. Okay. Thank you very much for being here.
Thank you, Professor.
Okay, you're welcome, guys. Stay safe.